Welcome to the sixth exercise in Chapter 5. Today we're focusing on surface area of only cylinders. So let's get into it. Now, we know what a cylinder looks like, and if we look at this diagram, I've shaded the base and the top. They are circles. So we have two circles, and then we have a depth which creates our cylindrical shape. But how do you find the surface area of a cylinder? Well, you can look at each of the two circles individually. So we've got two circles. There's our circle that was on the top and it was on the bottom. So the area of the top circle is pi r squared. The area of the bottom circle is pi r squared. It's this curved bit, the tubular part if you like, that we now need to deal with. So let's imagine that we unwrapped it a little bit. So we're going to go through the unwrapping process and it actually becomes a rectangle. Now we know the height of the cylinder is h, so the height of the rectangle we can call h. But what is this length here? Well, this length here came from when we wrapped our rectangle around into its cylindrical shape. It's that distance there, which is a circle, and the circumference of a circle is the distance around a circle. So that's what we're actually after. And the circumference of a circle is 2 pi r, which means this length of this rectangle is also 2 pi r. Now the area of a rectangle is the length times the width, so the length times the width will be 2 pi r times h, which is 2 pi r h. Now, that means if we want to find the surface area of a cylinder, we look at our three parts and we add them together. 1 pi r squared plus another pi r squared is 2 pi r squareds, and I have my 2 pi r h. There's the formula for the surface area of a cylinder. Now, there is another way you can write it, but I'm not going to worry about showing you that because I don't want to confuse you at this stage. We'll work with this way. Now, there's our formula, our summary. When we have a cylinder, that's what a cylinder looks like. We've got a radius and a height. The formula to find the surface area is 2 lots of pi r squared plus 2 lots of pi r h. Now, something we need to be careful about, sometimes cylinders will have both ends closed. So that's called a cylinder with two end circles. It's a closed cylinder. Sometimes you might have a cylinder where one end is blocked and the other one is hollow or open. So a cylinder with one end circle. And sometimes you'll have like a pipe where there's no circle on either end. It's called an open cylinder. So two end circles, one end circle, or 0 end circles. How does that affect the formula? Well, our formula is going to be affected based on how many circles there are. Each of the formulas has a 2 pi r h in it. This has two end circles, this has one end circle, and this has 0 end circles, which means you don't actually even have to write that section there. Let's try some examples. Find the surface area of a cylinder with a height 10 centimetre and diameter 6 centimetres. If it doesn't mention anything about end circles or whether it's hollow or open, you always assume that it's got two end circles. So a quick sketch. I've got a height of 10 and a radius of 3. The question said the diameter was 6, so all of the way across is 6, half of 6 is 3. The radius is 3. Need to be careful with that. 3 lines of working. Formula. What I type into the calculator? An answer. And so there are your values. In this case, the surface area of the cylinder, because we know the radius is 3 and the height is 10, turns out to be 245.04 centimetres squared if I round to 2 decimal places. And remember, that sign there means approximately equal to. It's telling me that I have rounded it to 2 decimal places. Let's look at our second example. Find the surface area of an open cylinder. It's got no ends. The height is 1 metre and the radius is 40 centimetres. There's a problem. If the height is measured in metres and the radius is measured in centimetres, they're different units of measurement. I need to convert them to both metres or both centimetres. In this case, I'm going to make them both metres. I know the height of my cylinder is 1 metre, and the radius, instead of writing 40 centimetres, so I know 40 centimetres is 0.4 of a metre. I could have called this 100 centimetres and 40 centimetres and then got my answer in centimetres squared. But I'm going to get my answer in metres squared. Now, when I write the formula down, this part here, the 0 pi r squared, you don't have to write. I'm just putting it there so you recognise because it's a cylinder with no ends, it's hollow, there are no circular ends. We just have to do 2 times pi times radius times height. We know the radius is 0.4, we know the height is 1. So we put that into the calculator and the area is 2.51 metres squared. Let's look at our next example. This is actually a half cylinder. Now when you have a half cylinder, you've got to be careful because it actually adds a slightly new dimension to the question. When I look at this particular question, I actually have the height, so that's the distance from the front semicircle to the back semicircle. The height's 250 centimetres. The diameter is 60 centimetres, so that's all the way across there, or I could have put it there, which means the radius is 30 centimetres. Now, if I look at the bit I've shaded in yellow, that's not actually part of a cylinder. Because I cut the cylinder in half, I've now exposed a rectangle. And if I'm finding the surface area of this entire shape, I've got to find the surface area of half of my cylinder as well as my new exposed surface, which is a rectangle. So, to find the surface area of a half cylinder, there's the formula for the surface area of a cylinder. I put a half in front because I only want half of a cylinder, plus the area of the yellow shaded rectangle that I've introduced because I cut the full cylinder in half. Now I know the radius is 30, I know the height is 250. For the area of the rectangle, it's going to be length times width. Put those values into the calculator, and I get a surface area of 41,389.4 centimetres squared if I round it to 1 decimal place. So that's how we're going to do a half cylinder question. Time for you to try some questions, and as usual, enjoy the experience because after all, maths is fun. Bye for now.